Welcome to my lesson. So this is a lesson going back again to the solution of linear systems. I've spoken about this. In fact, I have shown to you ways to solve linear systems. I think that was in the second recorded video lesson. But I want to go back to linear systems because of other things which I think I forgot to talk about. So in this lesson, I will go back to the methods to solve linear systems: substitution method, elimination method, and graphical method. And this is what I want to talk about. This is what I missed talking about when I introduced to you systems of linear equations, the type of linear systems. So there are linear systems that has no solution. Okay? Sometimes it's called an inconsistent system. Now, there are linear systems wherein you have one unique solution. The system has only one solution. But it can happen that the system has infinitely many solutions. Not just one. Yeah, it has a solution, but it has infinitely many solutions. Let us solve this by substitution. So our linear system is composed of x plus 5y is equal to 1 and 2x minus 2y is equal to 5. Let us do this by substitution. So from the first equation, okay, we can replace x by 1 minus 5 times y. Okay? Look at that. And you know what's going to happen. Okay, so we will replace x by this. That is why it's substitution. So from the second equation, we have 2 times x. Okay, but x will be replaced by this. 1 minus 5 times y minus 2y is equal to 5. Okay? And the result is one equation in one unknown. Okay, that is always the direction of your solution. Coming from a system of two linear equations in two unknowns, you go to one equation in one unknown. Solve for y. Okay, this one is distributive property of multiplication. This becomes 2 times 1 is 2 minus 10y minus 2y is equal to 5. So minus 10y or negative 10y minus 2y is negative 12y. And then transposition, 5 minus 2 is equal to 3. Solving for y is equal to negative 1/4. We already have a value for y. And so you know now what's going to happen to get a value for x. Pick any equation. Pick any equation in your system and then solve for x. So let us pick equation number 1. X plus 5y is equal to 1. That becomes x plus 5 times negative 1/4 is equal to 1. Solve for x. X is equal to 1 plus, okay, transposition, 1 plus 5/4. And that is equal to 9 over 4 or 2 and 1/4. We now have a value for x. And be careful with how you write the solution. So you will write the solution in terms of coordinates. The x and y is the set of coordinates for your point. So the first coordinate is going to be x, 2 and 1/4, and this is y, the second coordinate. So that is how you do it by substitution. Let us solve a new system, but this time let us do it by elimination. So the word itself is suggesting to you what you must do. You must eliminate one variable and one equation. I will multiply negative 2 to the first equation. Okay? Why would I do that? Well, the result is what will tell you why. Okay? So the first equation, when I multiply it by negative 2, this becomes negative 2x minus 6y is equal to negative 2. And then you add the two equations, and that is how x gets eliminated. Okay, so you add. This is eliminated. Negative 6y minus 2y, okay? Addition is going to be negative 8y. Negative 2 plus 3 is 1, okay? So y is equal to negative 1 over 8. So that's it. You already have a value for y. What now is the value for x? Let us go to the first equation and solve for x. Okay? So x, look at that. X plus 3 times y. Okay, y is negative 1 over 8 is equal to 1. Solve for x. X is equal to 1 plus transposition. 1 plus 3 over 8. That is 11 over 8. And so that is 1 and 3/8. Again, be careful with how you will write the solution. Okay, it's xy. So the first coordinate must be 11 over 8, this one. And the second coordinate is negative 1 over 8. Let us do it by graphical method. Well, what you do is you open an app or without an app. During our days when we didn't have these apps, we get a graphing paper and we sketch the graph and then we estimate the point of intersection. So the solution to a linear system is the point of intersection. Look for the point of intersection. Okay? Now, the apps, the free software that I often use is GeoGebra. Okay? So I sketched the graph and this is what I saw. Okay, so this is their point of intersection. And so this would be the coordinates of or this will be the solution. Okay? That is our interpretation of the solution to a linear system. It is the point of intersection. And so in this case, the coordinates of your solution is going to be negative 6.5 and negative 4.5. Okay? This is what I missed talking about when I introduced the linear system, the types of solutions. So you have cases wherein you have no solution. There are cases wherein you have one unique solution. Okay, it's like you have one solution only. And you have a case wherein you have infinitely many solutions. So a system of linear equations in which the lines are distinct and have same slopes. I'm sorry, I don't know why it gets doubled. When you have two distinct lines, okay, and they have the same slopes, then you are talking about two distinct parallel lines. And you know that they have no intersection, which means they have no solution. So what you do when you are given a linear system, okay, just to check what type of solution are you going to have, what you do is you write the equations in slope-intercept form, okay? When they have the same slopes and different y-intercept, then you are looking at two distinct lines that are parallel, in which case the system has no solution. Now, if you don't want to do it that way and you want to solve the system using either elimination or substitution, what you can do is you proceed with the method of your choice. Okay? And then along the way, if your solution produces something, an equation that is so false, an equation that is false, it can't be true, that is when you come up with a system with no solution. Solve. Of course, I chose this example to show to you the case of a system wherein the system has no solution. So I am not going to write this in slope-intercept form. No, I will solve this in the normal way that we use to solve systems. And in particular, I want to use the elimination method. I will multiply negative 1 to the first equation and add the two equation. Okay? And this is what I got. Look at that. When you add these two equations, the equivalent equation becomes, this is 0 plus 0 is equal to 1. And you know that 0 is not equal to 1. So this is like a false statement. What does this tell you? Well, it is telling you that the system has no solution. Other books call the system inconsistent. Okay, when it has no solution, the system is inconsistent. You have a case wherein the system is consistent, which means it has a solution, but infinitely many solutions. You don't just have one, you have many. Well, that can happen only when it turns out that the lines that you are working on, the equations that you are working on are equivalent equations. They are equivalent equations. They are pointing to the same lines. Okay? For example, this one. At the initial glance, it doesn't look that they are equivalent lines, but they are equivalent lines. Okay, let us show it. Look at this. 2x minus 2y is equal to 1. When you multiply that by 2, okay, so this becomes 4x minus 2y is equal to 2. And that is also how we are defining the second equation. So basically what happens here is you have two equivalent equations. They are equations of the same line. Okay? So what then is the solution? If you are working on a line, okay, so that means all points that lie on this line is going to be a solution to the system. And you know that a line has infinitely many points, and that is why the solution to this case is an infinite set. It has infinitely many solutions. Okay, if that is so, okay, if it has infinitely many solutions, can you give me one solution? So that is the challenge. Okay, why don't you give me one? Well, what you will do is something like this. Look at this. So we can write that as y is equal to 2x minus 1. Okay? Okay, so give me one solution. If this system has infinitely many solutions, well, why don't you give me one solution? Okay, so this is what you do. You pick any value of x. Let's say, for example, x is equal to 0. When x is 0, y is equal to negative 1. The point with coordinates 0, negative 1 is one solution. So that is how you generate the points that is a solution to this equation. You just pick any value of x, solve for y. And that pair of numbers is going to be a solution to your system, which happens to have an infinitely many solution.